Alright, today this video will deal with radio waves and is sort of an introductory to the FCC tech exam. So we want to talk about radio waves, so let's draw what we call a representative of radio wave. And what a radio wave is something that's going to be moving back and forth. So let's get started. So a radio wave is something that's varying, and we generally look at a radio wave as something like this. Now, along this this axis is time, and what we want to do is we want to describe this wave. We want to describe the frequency of this wave. Now the frequency implies is change. So notice that it's varying, all right? And it's varying back and forth. So by definition, if we say the frequency is the variations over time, we are describing how this wave changes. So let's count it. So we have 1 variation, 2 variations, 3 variations, 4 variations, 5 variations, 6 variations. All right, and say this time here was 1 second, we would say this thing changed 6 times per second. Now, radio guys, all measures have things we call units. For example, if we wanted to say how tall you were, we might say you were 5 feet, feet being the units. We also might say you were 60 inches tall, where inches are the units. Another example of units is hot and cold. Say we want to describe how hot it is outside, we might say it is 80 degrees. Well, we also assign units to frequency, and the units we assign to frequency is called a hertz. Now that's kind of a funny name, but really the guy who did a lot of work in radios was Heinrich Hertz, and he did this 3 centuries ago. And we honor Hertz by assigning the units of frequency. So this wave that we drew up here would be 6 Hertz. But remember, this is 6 vibrations every second. All right, now this is important, and this will show up on a test. So the important thing to remember is that frequency is by definition variations per second, and the units is hertz. Now let me give you an example of things you might have heard. One of the radio stations in town is the Dog, and it is on a frequency of 97.3 megahertz. And this M over here, mega, means million hertz. So when you're listening to the Dog, the radio station, the Dog, it is putting out a radio wave that's got these vibrations of roughly 100 million variations per second, or 97.3 million vibrations per second, called a hertz. Okay, so now let's talk about some other characteristics. Let me clear the deck here. Alright, we're going to get our radio wave again, and I'm going to expand it out a little bit. So one of the other characteristics where we describe a radio wave is what we call its wavelength. Now the wavelength is the distance between the peaks. Alright, and we measure that, and that's called a wavelength. Now radio guys are kind of lazy, so we have described, rather than writing out distance or wavelength, we give this a funny symbol of an upside down Y. That is a Greek character, lambda. So when you see this upside down Y, we're talking about wavelength, and we're talking about the distance between the peaks. All right, and the units we typically describe wavelength in is meters. Kind of getting scrunched up here, meters. All right. Sometimes we describe wavelength in feet. Sometimes we describe it in inches, and sometimes we describe it in centimeters. But the typical units of wavelength is meters. So
satellite CBSA rising.
The wavelength is the distance between the peaks on a wave. All right. Now I want to talk about one more characteristic. So let me get us a new board here. And we got our typical radio wave again. Now a radio wave travels at some speed. And radio waves in free space or air travel at the same speed of light. All right. And because we're again lazy, we have assigned the letter C to imply speed. And it turns out that radio waves and light travel at 300 million meters per second. Now that's pretty fast. Let me give you an idea of how fast that is. Say we have the Earth here, right? And we actually have a radio broadcasting out, and that signal goes all the way around the Earth. How long would it take for that radio wave to start to come back from where it started? Well, it turns out that it takes about 1/4 of a second. So now you get an idea of how fast that radio wave is. That's pretty doggone fast, right? So now let's kind of review what we've learned so far. Is that basically we have the frequency, and by definition that's the number of vibrations per second, and its units is in hertz. We have talked about its wavelength, lambda, which is equal to the distance between peaks. And its units is typically meters, could be other things. And we have talked about the speed at which it travels, which we give it the symbol C. and typically that is meters per second. Alright, so we've essentially described radio waves using three terms: its frequency, its wavelength, and the speed at which it goes. Alright, so in the next video we're going to talk about the relationship between these three descriptors. So in your first lesson, we want you to think about how to describe radio waves. And again, there's three ways to describe a radio wave: its frequency, its wavelength, and its speed or velocity. All right, till next time, so long.